Hello, my name is John DeDecker, Vice President of Exploration for EskayMining Corp. I'd like to talk to you today about our scientific approach to mineral exploration on our property. EskayMining's property is outlined here in yellow. It's in the heart of the Golden Triangle in northwestern British Columbia and comprises numerous precious metal showings, the majority of which are volcanogenic massive sulfide deposits or VMS deposits. We have several notable neighbors, including Eskay Creek, a world-class gold-rich VMS deposit just to our north, as well as Garibaldi's E&L magmatic nickel copper deposit, Seabridge's KSM iron cap deposits, Bruce Jack, and Treaty Creek. So we're in a very prolific district. Looking at VMS deposits, why do we want to explore for these things? Well, you can see on this graph, we have deposit tonnage on the x-axis and gold grade on the y-axis. And what we see here is that VMS deposits, some of these aren't very large as way tonnage goes, but very high grade and gold because they're very, discrete sulfide lenses that aren't disseminated like a porphyry, for instance. And they also tend to occur in clusters, structurally controlled clusters, such as a lot of these in the Abitibi district right here. So to understand the exploration approach that needs to be taken for VMS deposits, it helps to understand how these systems form in the first place. These hydrothermal systems occur in submarine extensional settings where we have our synvolcanic extensional fault serving as a conduit for cold seawater to penetrate into the seafloor, where it becomes heated up and modified through fluid rock interaction, picking up metals, including gold and silver. And then the fluids begin to ascend as they become heated over the rift-related intrusion. And as these fluids ascend, they hydrothermally alter the rock in this upflow zone, as well as introduce stringer or feeder zone style sulfide mineralization. And then the fluids vent onto the seafloor. And it's this big change in temperature from 2 degrees Celsius seawater to the 350 degrees Celsius hydrothermal fluids that actually causes metals to precipitate out of solution in a temperature dependent manner, forming these VMS mounds. Now, this is a cross-sectional view of a VMS system. They occur along strike from each other. This is an example from the Juan de Fuca hydrothermal field off modern day Pacific coast. And you can see that these hydrothermal vents occur along segments of the Juan de Fuca rift. And you get an enhancement of fluid flow where you've got offset of these rift segments along transform faults. And this is something that we see as well in the Abitibi district, notably the Millenbach deposit, where you have your synvolcanic extensional feeders serving as a hydrothermal conduit, but then you get the larger deposits where you have these offsetting transform faults. These VMS systems can form stacked deposits. That's because these hydrothermal systems like periods of volcanic quiescence. So you'd have a horizon, this lower horizon, you could get right here, because you have your venting onto the seafloor. That hydrothermal activity is punctuated and ended by subsequent volcanism, which basically clogs up the hydrothermal system. Once that volcanism subsides, the hydrothermal system becomes reestablished and precipitates a new sulfide body on the seafloor. And a lot of times these mineralized horizons correspond with mudstone horizons. And that's just because this punctuation and volcanic activity is accompanied by sedimentation of mud through the water column onto the seafloor. So that mud's really just representing a period where it was able to accumulate without being disturbed by volcanism. And the same thing goes with the hydrothermal system becoming established. And the situation can repeat itself multiple times going up stratigraphy. So looking at Eskay Creek itself, this is a cross-section modified from Skeena Resources cross-section of the 22 zone. It shows where their historic mine was at the contact mudstone clastic mineralization horizon. This is just debris flow hosted massive sulfide fragments within the mudstone. And that's at the contact between the rhyolite and basalt. We call this the contact mudstone. However, newer drilling by Skeena Resources has shown that they indeed have more than one mineralized horizon, including the lower mudstone and the even lower mudstone horizons. And I'll show that we have both of these horizons on our property as well. So looking at the anticline itself, this is from Skeena Resources, and Eskay Creek is up here on the northwestern nose of the Eskay anticline. Proceeding along the west limb of the anticline along strike, we get into our property down here where we have some enclaves up into the southern part of Skeena's property, and then we get into our property down here. What we see is this favorable Hazelton group stratigraphy here. The Hazelton group is our package of volcanic rocks divided into the lower Hazelton group for our arc-related volcanic rocks and the upper Hazelton group for the bimodal rift-related volcanic rocks. And then these would be overlain by the Bowser Lake group, which is a post-volcanic sedimentary succession. But it goes to say that we've got the exact same stratigraphy that Eskay Creek has going onto our property at the SIB showing. I don't want to dive too much into detail about this. However, there have been some reinterpretations of the structural geology in the area. Notably, the Coulter Creek thrust fault was traditionally viewed as an east dipping thrust fault. We felt that this didn't make sense, not only with the tectonic environment where you had in the Jurassic terrains accreting to the western margin of North America. You would expect in this sort of collisional environment more west dipping thrust faults, but it also doesn't agree with any of the data we have from drilling. It's just not an east dipping thrust fault. It actually dips to the west, and that's what this revised map right here shows. It also shows that we have numerous zones of gold enrichment occurring at stratigraphically favorable horizons, which is many more horizons than just the contact mudstone that was previously the focus of exploration. We're able to show that we indeed have our Lulu zone as correlative with the lower mudstone at Eskay Creek. And then we have our Bruce Glacier felsic unit zone, which is correlative with the even lower mudstone at Eskay Creek. But we also have significant gold enrichment within the Spatsizi formation of volcanoclastic sedimentary rocks, which is also something that Skeena Resources has drilled into at the Tamakai zone, just north of our border. And then we've been able to share that we have some zones within the Betty Creek formation andesites as well. So I noted that we have a west dipping Coulter Creek thrust fault. That is for the most part true, except for around the Lulu zone where we actually have a wedge style back thrust. So the bulk of the displacement is occurring along this west dipping thrust fault. However, we do have a wedging of the Bowser Lake group into the Hazelton group stratigraphy right here. And that's essentially split our Lulu zone into an upper and what we propose to be a lower Lulu zone that has yet to really be tested with drilling. And then we do have our evidence. I did a systematic examination of as many of the fault contacts or contacts between the Bowser Lake group and the Hazelton group as I could. And in every case, I noted that we have faulting. It's a fault contact without a doubt. These photographs are representative of the sorts of contacts we see. between the Bowser Lake group and the Hazelton group, with the Bowser Lake group accommodating the majority of the brittle deformation, going well upwards of 20 meters into the Bowser Lake group, whereas the Hazelton group is more competent, and you really don't see much in the way of brittle deformation more than 5 meters from the fault contact. So we have a proposed sequence of tectonic events for SIB and the district in general, which includes our arc-related volcanism. This is what gives us our andesites on the property. And then slab rollback of the subduction slab induces back arc rifting and begins the formation of our back arc submarine basin. And this is noted in stratigraphy by the presence of volcaniclastic sedimentary rocks of the Treaty Ridge member, if you're using Lewis's 2013 nomenclature, or the Spatsizi formation using Nilsson's revised nomenclature from 2018. But then we get into our inception of the rift-related volcanism. This is where we start to get our early stage felsic rocks erupting before it converts to more of a bimodal rift-related volcanism, where you initially have more of your felsic material erupting, becoming more and more basaltic over time until it's exclusively basaltic, and then the termination of volcanism and the deposition of our Bowser Lake group sedimentary rocks on top of the basalt. And it's worth noting regionally that this contact has been considered a conformable contact, which also lends support to our thrust fault hypothesis that the Bowser Lake group, when it's in contact with the rhyolite and some of the other Hazelton group rocks, is in a fault contact, not an angular conformity or some other style of contact. However, we get the continued accretion of terrains to the western continental margin, deforms the rocks, folds these rocks up into a series of anticlines, and then thrust faulting displaces these anticlines on top of each other, which is putting the Bowser Lake group over the Hazelton group rocks, because we're essentially, putting younger rocks over older rocks because the folding happened first. So it makes sense. That was one of the critiques of the west dipping thrust fault, is that you have to have older rocks thrust over younger rocks. That's only the case if you're dealing with horizontal, previously undeformed rocks, which is not the case for this area. We are doing a very detailed chemostratigraphic examination of all of our rocks and drill core using immobile elements. I would be happy to talk about this in more detail at some future point, but it goes to say that we are able to, using aluminum, titanium, and some other elements, really get a good control on the identity of the volcanic rocks we encounter in drill core. And this is important because a lot of the pre-2017 drill programs on the property just didn't identify the rocks properly. You really have to put the effort into logging your drill core properly if you want to make any sense out of anything geologically. And it's important because we are dealing with stratiform sulfide bodies, so you need to know something about the stratigraphy. And then we have here another example using our niobium yttrium ratio over versus zirconium titanium ratio, again showing a very good separation of these different rock units. And this is essentially to serve as a quality control on logging and to ensure that we have a quantitative way of ensuring that our drill core has been logged properly. And then this will allow us to correlate these stratigraphic units all across our property. We're also utilizing our geochemical information to quantify the alteration intensity. We're using the alteration box plot developed by Ross Large et al. For VMS deposits. This is something that has not been done in the district. As a matter of fact, some previous workers on our project walked away because they said the rock wasn't hydrothermally altered. However, they are just looking at sodium versus potassium alteration, which is essentially a one-dimensional view of a multi-component alteration system, which the alteration box plot captures much better. And we're able to show that our gold grade, which is noted by the size of these dots, actually corresponds with intense alteration, which you can see is over here in this field. So we have intensely hydrothermally altered rocks. Also did a systematic relog of several drill holes of over the property, including our representative hole at SIB Lulu 02113, which the highlights of this are that we indeed have multiple mineralized horizons. So this would be our mudstone, peperitic mudstone within the Eskay rhyolite. And then here we have our gold grade getting up to, in this case, in this hole, about 50 grams per ton, and then well over 1,000 grams per ton silver here. But you can see wherever you get these mudstone layers within the rock package, you're getting this elevation in gold content. This would be Skeena's lower mudstone and then the even lower mudstone unit. I noted that we do get mineralization within the Spatsizi formation. And this drill hole, we don't have any data because these workers didn't assay every interval of drill core. That's important. We've noted in many cases that drill or rock that looked like it didn't have anything in it actually runs with gold. So don't just use a visual inspection to decide what you're going to assay. It's really worth assaying every meter interval of your drill core if you can afford it. And then in other holes, though, I should note, we do get a good grade within the Spatsizi formation. And then going down into the Betty Creek formation, we have our dacitic breccias here, which do run up to 1/10 of a gram per ton gold. This is anomalous. And I'll show at our TV and Jeff deposits actually can get into bonanza grade gold down within these lower units. And then further down into the andesite, there's actually 3 intervals of brecciated to peperitic mudstone that runs up to 1 gram per ton gold in this case, suggesting that even further down stratigraphy, there are more of these mineralized horizons to explore. This is an example of drill core from the Lulu zone, just showing our intensely cerussitized peperitic rhyolite. And then approaching the Lulu zone proper, you get our a silicified black mudstone with massive meargyrite and stibnite mineralization. And then underneath this, or the lower contact, I should say, of this mud is again another peperitic contact with rhyolite, indicating that the rhyolite has intruded into this mineralized mudstone and actually split it up into different horizons. It is a peperitic contact. And then we have other examples from a nearby drill hole showing that we actually get into massive meargyrite, our dominant silver mineral, plus antimony and banded barite. Looking with the electron microscope at our Lulu mineralization itself, what we see is intense hydrothermal alteration. We have barite, celcine, which is our barium feldspar, and quartz, all hydrothermal minerals, and then our meargyrite. We do get some illite and some carbonate minerals as well. So this is again consistent with the sorts of mineralogy that the alteration index suggests exist on this property. And then we're also able to show that gold primarily is occurring as electrum within these rocks, running up to 60% gold and 40% silver. So we've got our schematic, not reconstructed cross section. This is a schematic cross section showing our Bowser Lake fault wedge, where we know we've drilled into these favorable horizons. However, I should note our Lulu horizon right here, really hasn't been tested out below this fault wedge before. Previous drilling kind of stepped to either side of the Lulu zone and missed going underneath this fault wedge. But what we have seen from our previous drilling is that we've encountered right at the stratigraphic position I would project our Lulu mudstone to be at, that we actually do encounter pepperitic mudstone within rhyolites over a meter scale distance. So this indicates that very likely we may be on the flanks of a larger mudstone or pepperitic horizon underneath our Bowser Lake group fault wedge, which opens up the prospectivity for finding a lower component to the Lulu zone. And we do get several, these are interpolated grade shells from other drill holes, indicating that you probably have a feeder zone coming up into this system. So looking at stratiform mineralization for SIB as a whole, what we've done here is include our alteration intensity. Our gray is our carbonate chlorite pyrite index. This is everything that's intensely altered in that fashion. And then our pinks and greens down here by the Lulu zone show where we've got intense sericitic alteration down here. But it shows that we've got these zones of that are strata bound zones of mineralization that seem to be forming a hydrothermal system going up stratigraphy towards our presumed exhalative horizon associated with intense hydrothermal alteration, just as you would expect for a VMS system. And I should also note this is the Tamakai zone here, drilled by Skeena Resources just north of our border, and some of our best drill intercepts from the 2018 program, 61.9 grams per ton, and EK 18160 here show that this zone continues to the south, and as you can see, continues much further south. We're talking up to 4 kilometers of strike length with this prospectivity. But previous programs really kind of ignored a lot of this as they were trying to focus on the Eskay Creek contact mudstone horizon. Now we've developed an understanding that there's more to these properties than just the contact mudstone. So expanding to property-wide prospectivity, briefly want to talk about the broader structural geology here. This is a synthesis of information from our own drilling, from Peter Lewis's 2013 map, as well as newer structural data acquired from the British Columbia Geological Survey. But this is our interpretation of the property, utilizing our magnetic survey in 2019 as a base layer, showing that we actually have 3 anticlines extending the length of the property. These actually define where our mineralization or a good gold grade encountered either through drilling, through surface sampling, or through our latest stream sampling program, our BLEG program, define trends of mineralization that lie along the limbs of each of these anticlines that are bounded by thrust faults, forming a full thrust ramp complex, just as you would expect in the tectonic environment and tectonic history for this area. And this really opens up a property-wide exploration model where we're looking for a favorable Hazelton group stratigraphy, and we're also looking for multiple horizons of stratiform mineralization. So we've got a lot of prospectivity on our ground. So looking at our TV and Jeff showings, this formed the focus of our 2020 drill program. We're looking at a trend developed using historical drill information from the mid 1990s, showing that we had some gold enrichment lying along a trend of 12 degrees in azimuth and dipping about 45 degrees to the east. We were at this point still trying to show that we were dealing with the east limb of the Eskay anticline here, further to the south, further south than it had been mapped previously. And Um, Indeed, we've shown that these zones do dip 45 degrees, trending 12 degrees to the northeast, and we've actually been able to infill and expand a lot of these zones. So we know that these things are real stratiform stacked sulfide systems. And then we've done a SkyTEM conductivity survey, an airborne survey that was able to show that our mineralized zones correlate with moderate to high conductivity anomalies seen by SkyTEM, but we're also getting additional anomalies of similar intensity and morphology along strike from TV and Jeff, as well as up stratigraphy from TV and Jeff. And I'll mention more about this briefly, but we also have additional chargeability anomalies lying on the west limb of the Eskay anticline. So this is essentially a repeated stratigraphy on both limbs of the Eskay anticline, both showing the same sorts of chargeability anomalies that are consistent with what we see where we have sulfide mineralization. So looking at our TV deposit, the stratigraphy is representative of Jeff as well, where we're so far have drilled in to the Betty Creek Formation, dacite and mudstones seem to be harboring or hosting our gold mineralization. Again, within peperitic to brecciated rocks, very similar to what we see at in the Betty Creek Formation at SIB. But historic drilling has intercepted sandstones of the Spatsizi Formation, and we are inferring that we've got more felsic rocks up stratigraphy based not only on our stratigraphic up direction going to the east and uphill, but that we're actually into this resistant felsic unit. Other felsic rocks on the property form ridges and bluffs that are resistant to erosion and form a geomorphic expression. That's what we see here. We also did a IP survey at TV and Jeff, which has shown that we do get similar sorts of chargeability anomalies up in this upper stratigraphy that has never been drilled into, as we get with where we know we have mineralization in our upper and lower zones. So this opens up the potential for extending this hydrothermal system all the way up to the Eskay rhyolite, just like we have at SIB. Looking at the drill core itself, what we see here is semi-massive to massive sulfide and placed within a dacitic pepperite to a mudstone. And some preliminary electron microscopy has shown that we do have a hydrothermal alteration suite, in this case of barium feldspar and illite, with euhedral pyrite being replaced or overgrown by arsenopyrite, which is in turn replaced and overgrown with antimony enrichment, which is similar in some respects to what we're seeing at Lulu, but we still have more work to do on the petrography for TV. Jeff, as I mentioned, is very similar to TV, similar stratigraphy. We did encounter bonanza grades of gold and silver at Jeff, meargyrite, pyrargyrite, and electromol, all observed in drill core. And in some cases, we're getting up to 84.4 grams per ton as our best intercept to date. But with our latest press releases, this was the drill hole that encountered tens of meters of really good gold grade, able to show again the same correlation between mineralization and chargeability. We did again our litho geochemistry and chemostratigraphy to show where we are in the rock package, and we're also able to show again that hydrothermal alteration corresponds with gold mineralization. We have more than TV and Jeff, though. As you go along on the trends of these newly defined anticlines, we see on our quarry showing our 100% ground that's not in 20% JV with Kirkland Lake, that we have several other showings. Cumberland, again lying on the west limb of the Eskay anticline, TET and C10 on the east limb of the Eskay anticline, a long trend from TV and Jeff, and then we step across our thrust fault here onto our eastern anticline, and then we get GFJ on the west limb, and then Spearhead and AP, and several good stream samples and surface samples along this eastern limb of the anticline. Again, we've done some IP surveys for some of these other showings and have been able to show that our interpolated grade shells correspond really well with chargeability anomalies. It seems that these chargeability anomalies are defining our favorable strata-bound sulfide horizons here. So far, in most cases, that's what we've drilled into. So we're going to be exploring in 2021 down at TET and C10, GFJ and Spearhead to drill into these anomalies to start to get some idea of what exactly things represent across the property. TET and C10 I interpret to essentially be just a more metamorphosed version of TV Jeff. It's within Betty Creek Formation rocks. And here we have our surface expression of our silver sulfur salt vein right here up on Mount Madge. And then again, overlooking our C10 zone here, we see that we've got this more massive metamorphosed andesite that has several of these really foliated, more oxidized trends, trending 315 degrees, kind of the broader structural trend. And these seem to correspond with what we see in drill core with better gold grade. Looking at the rock itself, this geochemically is consistent with being an andesite. However, it is intensely hydrothermally altered and metamorphosed up to green schist facies. And you can see it has quite a bit of foliation. Euhedral pyrite is disseminated throughout the rock, and then the ground mass has been, in the cases of these auriferous zones, you get up to 100 grams per ton gold, been completely obliterated and replaced by hydrothermal or metamorphic clays, quartz, carbonates, and epidote chlorite. So we're going to be planning a drill program, as I mentioned, at TET C10 GFJ in 2021 that will explore not only the strand-bound nature and correlation of these gold grades with the chargeability anomalies, but also be integrated in our mapping program to really test out our hypothesis of these stacked full thrust ramps down here to the southern part of our property. That said, GFJ, these IP anomalies really correlate well with good surface samples that have quite good gold grade from surface sampling. Spearhead, again, on our eastern anticline, appears to be at the Spatsizi Formation Bruce Glacier felsic unit contact. We've got our volcaniclastic conglomerate here, and then these sulfidized mudstones are within a rhyolitic to felsic rock package, but it outcrops on the surface and extends to the southeast for over 100 meters with this gossinous bluff here. So we'll be doing extensive surface mapping and drilling and some exploratory drilling at Spearhead this season. So I'd like to thank everyone for their time today. And if you have any questions, you can feel free to email me at my EskayMining email address or ask questions during our question and answer session. Thank you.